All right. So 1.6 is all about this thing called transformations. The word transformations is a fancy word to describe how graphs move up, down, right, and left, and reflections. So transformations, again, is going to be up, down, right, left, and reflections. And then I'll get into stretching things more tomorrow, the next lesson, okay? So we're going to begin with vertical transformations. When you see the word vertical, which direction do you think of? Up and down, right? Vertical is up and down. So we're going to talk about up and down transformations first. So if I give you any function from that list of 12 that I just gave you, y equals f of x, and if we add on a constant, like the number c, then that is going to imply, and of course the double arrow means implies, that you're going to go up however many c units is. Okay, so any function f of x plus c means you go up c units. And if I gave you y equals f of x, take that same logic, if I said minus c, what would you guys think? We would go down. You got it. We would go down c units. Okay, this is the basis for moving graphs up and down. Okay, take a look at this example here. If I gave you f of x is the square root of x plus 4, all right? Well, what are we doing? Am I adding a number on the end of that, or is I subtracting a number on the end of that? I am adding 4, so what would that imply? I would go up 4 units. Now, here's what I want you to be able to do as the student. I want you to be able to look at that equation and say that is the square root function, which looks like a shark fin, that has been moved up 4 units. That's what I need you to be able to do, all right? So if we're going to plug this into the calculator and actually compare the two, go to y equals wherever you're at, clear everything else out. Whatever you got in there, clear it out. And punch in, if you don't know how to punch in the square root function, second square root. Oh, I don't know why it does that. Second square root of x. And then move your cursor outside and then go plus 4. If we compare that to the regular old function, you would see this right here. So the blue one is the transformation, a vertical transformation up 4 units. The red one is the original graph, f of x equals the square root of x. Okay, take a look at this equation. Absolute value of x minus 3. Tell me the parent graph, what would it be? It would be the v graph, except to be moved where? Down 3 units. So we'll do this a little bit more quickly on this version of things, okay? So let's get rid of this. So if I gave you the absolute value of x, everybody knows you should have the idea that that's the v graph. Then if I give you the absolute value of x, but I subtract 3, that should be, notice you moved down 3 units. So that is a vertical transformation down 3 units. You guys good with that? Okay, what about this one? F of x is equal to x cubed plus 7. What would that graph be? Okay, horizontal transformations. When you see the word horizontal, what do you think of? Left and right. Yes, very good. So I could give you this. Y equals f of x plus c. Now, take a look at that. How is that different from a vertical transformation? Take a look at that very first box. What's the difference? Where's the c, everybody? Yeah. It's inside the parentheses versus outside the parentheses, okay? So that's going to imply, that's for us, that is going to imply that this is going to give us a shift to the left. Unfortunately, you would think it should be right, but it is left c units. And then if it's x minus c, that would imply that it would be right, whatever c units happens to be. Okay? So there's everything you want to know about horizontal. Okay, let's look at this one. F of x equals x plus 3 squared. How would you describe this particular function? What's going on here? First of all, what's the parent graph? X squared, the parabola. Very good. Now, which direction has it been moved? Up, down, left, or right? Left 3 units. Let's see if you're correct, okay? So we're going to do, we wanted to do y equals, you guys told me it was x squared. That's this one, easy enough. And then I gave you x plus 3, right, squared. And you told me it was 3 to the left. So if I put this on the graph, I have actually gone there 3 units to the left. And you can see that I have actually moved from the red to the blue. Okay? All right, let's do this one. What if I gave you this? F of x is equal to absolute value of x minus 4. What would that be? What graph, what parent graph would it be? Noah's correct. It'd be the V graph, except which direction it would be? Up, down, left, or right? Right, how many units? 4 units. Huzaifa says to the right 4 units. So if I give him absolute value of x, you should have some vague idea that that's the V graph. And if I give you the absolute value of x minus 4, you should know that that is 4 units to the right. Okay? Are we on board? You guys cool with that? Okay, good. Okay, everybody look up. So here's what I would like you to do. I've given you a picture of a graph. I want you to give me the equation that would produce this picture of the graph. And then test it out in the calculator and see. So talk to a buddy, look at the equation, or look at the graph and see if you can give me the equation. Okay, Huzaifa, what'd you come up with, buddy? I got 3, x minus 3. Is that what you just said? Yeah, absolute value squared of x minus 3. Very good, man. Right. Okay, for this graph, we're going to do these one step at a time. And we're going to graph each transformation that we do using a different color. And we're going to begin with the parent graph. So pick any color that you want. And we're going to begin by putting number 1 off to the side and saying that we're going to start with the parent graph. And what would be the parent graph for this particular function? It would be x cubed. That's the backwards s. So you need to know that these are what are known as anchor points for the backwards s graph. How did I get those so quickly? How do I know 0, 0 is on that graph? Huh? It's reflected from the origin. I know that too, but what else do I know? That's a great point, by the way. How would I get 1, 1 out of this? Just plug it in. Yeah, plug in a 1, get out a 1. So notice you have these 3 anchor points. So that's our first graph. The next graph that we're going to do is not that one. Sorry. The next graph that we're going to do is going to be x plus 2 quantity all cubed. So what is that going to do? What's the purple going to do to the black? Move it which direction? 2 units to the what? Left. So move your dots, all of your dots, 2 units to the left. Okay? And you are color coding this for me. And you're saying that that's the second graph that we have. And then finally, pick a different color. I'll go mighty pink here. The third one, I'll do f of x is equal to x plus 2 cubed, and then finally minus 3. So what would I do now? I would move each of my points which direction? 3 units down. You got it. So 1, 2, 3, there, and there. So I'd end up with a final graph that looks kind of like this. And if you're a cool kid and you want to be part of the cool kids club, then you highlight your final graph. Okay, so here is the setup. I've given you the original square root function, y equals the square root of x. That's the red one that you see on the page. I've also given you 2 other functions that I have not yet graphed. One of them is the square root of negative x. The other is the negative square root of x. Do you see the difference between the 2? Yeah. What is the difference between the 2 that I haven't yet graphed? One of them, the negative sign's on the inside, and one of them is on the outside, right? Okay, here's my question to you. One of these equations that I have not yet graphed will reflect that graph that you see, the red graph, over the x-axis. And the other will reflect that graph over the y-axis. My question to you is, which one is which? I want you to talk about it with a friend and make a guess, okay? Okay? So, this one, the x is on the inside. This is a reflection over the y-axis. Take a look. There it is right there. Okay? Because if I plug in a negative 3, or if I plug in a negative 4, check it out. The negative of negative 4 is 4. And the square of that would be 2. Okay, this one over here is a reflection over the x-axis, and there it is right there. Bonus question, how do I get it over both axes? The negative square root of negative x. Oh, boom, bonus question there, but we don't need to worry about that one, okay? So the main idea is this one here. So let's sum this up in our notes, okay? If you're given y equals f of x, then y equals the negative f of x implies a reflection over, what did we come up with here if it's the negative? The x-axis. So here's what you want to write down, right? If the negative's out in front, you're going to get a reflection over the x-axis. Similarly, if you want f of negative x, that implies we're going to have a reflection, REF period is reflection, over what? The y-axis. Very good. So here is the important information. If it's on the inside, we're going to have a y-axis. And there you go. That's everything you possibly want to know about reflections. I'm going to give you this function right here. Absolute value of x plus 2 minus 5. Our task for the end of the day here is to come up with the equation that would give me a reflection, I don't even want that there, a reflection over the x-axis, and to come up with an equation that would give me a reflection over the y-axis. That's our task for the end of the day. Give me two equations, one that will reflect this over the x and one over the y. So I'll start us off by giving us the original problem, right? What was the original one? Absolute value of x plus 2, and then what? And then is it plus 5? Minus 5. Okay. That is all messed up. Absolute value of x plus 2, and then minus 5. What will this graph look like, everybody? That's our V graph, and of course it is to the left 2, and then finally down 5. Okay, so our goal, come up with the, what's it going to be? What are we going to do? Let's make this a little smaller so we can see. How do we get a reflection over the x-axis? We actually put a minus sign in front of the whole thing. So we want the negative of our function, which is absolute value of x plus 2 minus 5. So do you see how I have the negative just outside the entire function? And I use big old chunky brackets, but it's the same thing as parentheses, right? So that would give me negative x plus 2 and then plus 5. Do you see that? The absolute value, the negative absolute value of x plus 2 plus 5. So let's go back to this and say y equals the negative absolute value of x plus 2, and then it was plus 5. That should be a reflection over the x-axis, and there it is up there. Can you see it? Yeah. And now I'll just go like that. There it is right there. Okay, looks like a mountain now. Okay, now how do I get then the reflection over the y-axis? It actually says replace x with a negative x, right? So I would have this. I would have, well, that'd be absolute value of negative x plus 2, and then a minus 5. Does that make sense? So then I go over here, and I would say y equal, well, let's go down here. Y equals absolute value of negative x and then plus 2, and then minus 5. Oh no. Let's get rid of that. There we go. There it is. The reflection over the x-axis. Yes.